What if the first builders on Mars aren't astronauts, but human-shaped machines? Today, you'll learn why we haven't sent humanoid robots to Mars yet, how close we are to doing it, and why these robots could be the missing link between today's rovers and future human colonies. Let's begin with the obvious. We haven't even sent people to Mars, and for good reason. Mars is far, on average, about 225 million kilometers away. A round-trip mission could take up to 3 years. The health risks alone are massive. Prolonged exposure to space radiation can cause long-term damage to the brain, heart, and DNA. Unlike the Earth or even the International Space Station, Mars has no protective magnetic field or thick atmosphere to shield us. Then there's the problem of gravity. On Mars, it's only about 38% of Earth's. We don't fully understand how that affects muscle, bone, or organ function in the long run. Logistically, landing a heavy spacecraft with humans and life support systems is still a major engineering hurdle. We've landed rovers, yes, but landing a large crewed habitat is another story entirely. Every kilogram counts, and failure is not an option when lives are involved. This is why human missions have been pushed back repeatedly, despite plans from NASA, SpaceX, and others. We're making progress, but we're not there yet. Now imagine this. Before humans ever step foot on Mars, machines shaped like us get there first. Not just rovers that crawl. Not just drones that fly, but robots that can walk, climb, carry, build, and adapt in ways that resemble human behavior without needing food, oxygen, or emotional support. Today's most advanced humanoid robots, like Tesla Optimus, Figure 01, and Boston Dynamics Atlas, are beginning to perform tasks that go beyond factory work. They can lift tools, pick up objects, maintain balance, and even respond to basic commands. Controlled remotely or partially autonomously, these machines are slowly learning to operate in unpredictable environments. And that's exactly what Mars is. Unpredictable, harsh, and unforgiving. A humanoid design isn't just for aesthetics. It allows these robots to use tools, climb stairs, open doors, and manipulate machinery made for human hands. Instead of redesigning entire systems for robots, we can train robots to use systems we already understand. Humanoid robots bring unique benefits to Mars exploration. Their ability to move over rocky and uneven terrain surpasses that of wheeled rovers, allowing them to access places otherwise unreachable. Because they are built to mimic human movement, they can handle tools, assemble structures, and repair equipment designed for people, making them invaluable for setting up habitats and infrastructure. Unlike humans, they require no life support, food, or rest, removing risks related to health and safety in such a hostile environment. Additionally, they can be operated remotely using VR and motion capture systems, enabling near-human control despite the long communication delays between Earth and Mars. This combination of adaptability, resilience, and controllability makes humanoid robots a promising solution to bridge the gap between robotic probes and human explorers. So if humanoid robots have all these benefits, why haven't we sent them yet? The truth is, we're getting close. In 2024, researchers controlled a humanoid robot using Apple's Vision Pro headset. It wasn't science fiction. It was real and shockingly responsive. The long-term goal? To prepare robots that could act as remote workers on Mars. Tesla's Optimus project has also hinted at potential use cases beyond Earth. Elon Musk suggested the robot could eventually assist with colonization tasks. NASA is investing in semi-autonomous robotic systems too. While they haven't formally announced a humanoid Mars mission, they are testing humanoid robots like Valkyrie in simulated Mars-like conditions. Also, private companies like Figure AI and Sanctuary AI are moving rapidly in this space. Their goal is to build general-purpose humanoids that could operate in extreme environments, including space. At this point, it's less a question of if and more about when. Sending humans to Mars may still be decades away, but humanoid robots could go much sooner. They're not replacements for people, but they can be our pathfinders, builders, and guardians on a planet that has never known life. If we're serious about colonizing Mars, we'll need help, and that help might look just like us, but made of metal. If you enjoyed this video and learned something new, drop a like and leave a comment with your thoughts, especially if you think robots should go before humans. Don't forget to subscribe for more videos like this. Space, AI, and the future of exploration all in one place. Remember, the future of Mars might just walk on two legs, but it won't be human at first. Thanks for watching.